Okay, let's get into his second video that we're going to watch here. I don't know where in the movie this is, but this has to do with measuring crossbeds. And here they are in the boat in the Grand Canyon, because everything's the Grand Canyon apparently. I know that sounds snarky, but honestly, that's all they ever do. They all ever take you to Mount St. Helens or the Grand Canyon. Except for Hove and Eric, who tried to take you to Baraboo, but screwed that up 3 ways to Sunday. He brought Austin with him. Other than that, he hadn't. Well, no, he said he had another geologist with him, but, you know, whatever. It's neither here nor there. The point is, everything apparently is the Grand Canyon with these people. You just need to watch any of their videos. Let's start watching this. This one is about 6 minutes.
All right, we are at about 1.4 miles on the Colorado River, right near the Navajo Bridge. This is the Coconino sandstone, and it's a cross-bedded sandstone, which means it has angled layers in it. You can see that the beds are not.
Okay, I want you to look at this here, because we do have horizontal bedding here, but we also have cross beds. Cross beds are beds that are not, how do I put this? Cross beds are beds deposited at an angle that isn't level or near level. There are many types of cross beds. These look like planar cross beds. Planar cross beds are like this, right? But you can still see from the picture, this is a generic cross section, that there are distinct bedding planes, and they vary about the cross bedding. You know, and they could go the other way too, it doesn't matter. So these are your cross beds. These are your bedding planes. These will be near level. This whole assemblage is a bed set. Okay? It depends on what you're trying to measure. If you're trying to get the strike and dip of the rock unit at a grand scale, you're not measuring those. Because it won't give you that. It will give you something, and you can measure them. I'll talk about here in a minute. You are going to want to measure these planes. That's what you're going to measure. Now, you can measure your cross beds to determine source direction. So you can measure them, get a strike and dip, like these, assuming we're looking along strike, your source direction would be this way. And you can see if that changes a little, see if it's more water-like, more dune-like, whatever. Although planar cross-bedding, it can be done in water-laying sediments. Big ones are rare. Usually they're going to be small, low-angle, stuff like that. But you can get wind ones at low angles too. It's not necessarily easy to decide which environment these were deposited in unless you look at the petrology of the sand, which hopefully he'll get into. So I just wanted to address that real quick. So let's move on here a little.
Horizontal or not flat, but they're at an angle. And I'm checking it out to see if we can get a good strike and dip measurement here.
At first glance, that looks alien to me. And he said strike and dip. Now what is that, Steve? For those of you that don't know, this is a basic measurement in geology. This is key. If you can't do this in the field, you suck as a geologist, okay? Because this leads to our predictive interpretations. We get enough of these, we can draw our cross sections and make predictions, and that helps us find things like water and minerals, okay? But the unit itself, how you take this measurement, you take strike and dip of a planar surface. You can do it on a cross bed. You can do it on top of a bed set. You know, you can do it wherever, but it's a two-part measurement. It's a strike and a dip. There are instances when you can't directly get this. Hopefully he'll go into that a little and I can talk about that. But I don't want this to become a big class for you here. That's not the point of this. But anyway, basically, strike and dip. You can define these different ways. Dip is always perpendicular to strike, down slope by definition. That's the easiest way to remember dip. Now your bed can be overturned, but you would represent that, but you can find evidence for that. But that's what it always is. Physically, it's perpendicular to strike in the physical downhill direction as you stand on that rock looking at it or looking at it from there. That's dip. What is strike? This is problematic. There's a real easy definition that no one says. And you go look at it online, they do the big complicated thing. Strike is the connection of a straight line between 2 points of equal elevation. Now in your Brunton, that's going to be this much, but it can be 10 kilometers apart too. All right. So it doesn't matter, you know, as long as obviously the curvature of the earth comes into play eventually. So if my strike is like this, but this is probably, I don't know, north 40 west. Now, by definition, my dip is perpendicular to this. And this is the symbol I would put on the map, but I wouldn't write this. So my dip has to be southwest or northeast. If I'm standing on there and I'm facing southwest and that's downhill, this is my dip. And then I take my dip measurement, which I hope he shows you how to do, and that would be 15 degrees southwest. I would write it in my field notes as north 40 west, 15 southwest. But if I was to put this on a map and map it, I would just do this. Why do we do that? Because I can take a protractor on the map and, you know, this way is dead north. Sorry. I forgot that. So I would take that and I could always put my protractor back on it if I need that. Obviously, this is a two-dimensional representation of a three-dimensional plane, and I can't measure the 15 degrees, so I have to indicate that's 15 degrees down slope. That's why we write the 15. If I just do this, it can be anything between 1 and 89, you know? So that's what it is. And what you do with that is, those of you that have followed me for a while, you can use that to draw turtles and draw cross sections. Okay, I don't want this to get too long, so let's move on here.
I think this will be good. So we're gonna be measuring the angle of these crossbed dips here.
Fine.
We have a special kind of compass called the Brunton compass. And with the Brunton compass, you can not only measure directions,
he has a
but
degree
you can turn
one.
it up on edge like this, and turn a little level that I have in here to measure the angle of dip. The first thing that you have to do is find the maximum angle of dip, or the maximum angle of slope in the crossbed. So my field book represents the angle of the Coconino bed.
I don't know how to address that. Most of us get strike first because it's easier with our Brunton. Now it is above his head. And I mean, I know he is giving a lecture to lay people who don't know this. But if you're going to usually don't find the dip first. You usually get your strike. And what happens if I'm up on a rock and I have a pencil, don't want to do pen, you can even have a thin marker if you want, is I will get that measurement with my compass and I will physically draw my strike right next to my compass because it'll be oriented a certain way. You know, my compass, this is just generic Brunton here. Oh my God, what is this? There's a mirror here. But, you know, it's more like this. If this is my strike with all my level bubbles, I will draw a line in pencil here, and then I'll get my dip perpendicular down slope to that, whichever way it goes. Sorry about the bad drawing. Let's try that again. Okay. Basically, you usually want to do strike first, and you have a pen or a marker with you, and you have a pencil or a marker with you. I recommend pencil. And your Brunton, you know, we'll just say this is a square part. This is my compass face. It has bubbles in here. I get them level. I get both of them level. This is a mirror part. Don't worry about the mirror. And then you have your sight here, which in this case you don't have to worry about either. You could actually fold it on top of the mirror. That's fine. And the mirror you can actually use to read the compass if something's higher than you too. You can use it there. But let's say this is my orientation. This is my strike. I would draw my strike line right against the compass with my pencil. And then depending if slopes this way or this way, I would just turn this thing. Now, I would put it up on its side and this way, perpendicular to my strike to get my dip. I think he'll probably show you that part of the dip though. So let's move on. So I always get my strike first, and that's the way I was always taught to do it.
And what I'm going to do is pour just a little bit of water on there, on that slope, and the water will run downhill, and however the water runs, that's the maximum dip. So I pour some water on there, and you can see the water is running down in that direction. And then what I do,
That's actually how you teach it. I have no problem with that. But you notice the water didn't run down the way that the dip in the crossbed looks by looking at the face of the outcrop. That's why you have to measure these. And there's a reason for that, because things don't always break along dip or strike. Matter of fact, they almost never do. Now, there is a way to get true strike and dip if you can't get it by actual bedding, and I don't know if he's going to address that or not. It's called a parent dip. It's a linear measurement. I've covered these before, but that's fine as a teaching tool, but I wouldn't do this to get my actual dip in the field, because that's a lot of water, and yeah, it's generally going that way, but when I put my Brunton on there, I could be off 10, 15 degrees, and that's going to mess with everything else. But for demonstration purposes, that's fine.
is take my compass and line it up parallel to the direction that the water ran. And I can move that little level around.
That's how you get dip. Like I said, he didn't show you strike, but that's the way you orient your compass. See, my line would be perpendicular to that I drew. And then you move that level and your degrees dip are on the bottom. And that's how you record that.
Until the level is centered right there, and then I can read the dip measurement in my compass. And the dip measurement right here says that the dip is about 17 degrees.
It looks about right.
Then I can turn my compass this way and find out that the dip is 17 degrees to the south, and that's a pretty common dip direction.
That's a lineation measurement. That's not strike and dip. Strike and dip, like I said, is two parts. You know? And you'd write it like north 35, west 15, southwest, okay? You'd write it like that in your field book. What he just did was a lineation, which is fine, but you can actually get strike on that rock. So why didn't you get strike? You can compute it. I mean, if I have a dip this way and I know I'm actually on my plane that I want to measure, and this is true dip, and it's south, I don't know, 60 west, that's part of the lineation. But if that's my dip direction, I can calculate this, all right, if that is my true dip. But why go through that bother when you can directly measure it? Because what he just gave you was a lineation. Lineations can be used to find true dip if you can't get strike and dip, true strike and dip. It's called parent dip. You need two measurements. So, if I have a lineation and I can't get my strike, and I don't know if strike is this way or this way or this way or whatever way, I have a lineation. And that lineation, I just take a measurement as is. Here it looks about south 45 west. Okay? And then I would get my dip like he did. And say it's 15 degrees. You would write it in your field book like this. Now, when you actually put it on a map, you would do something like this. Same thing, orientation is known. You know you're going this way. Unlike true strike and dip, which are always oriented to the north, always. So your strike is always going to be to the northwest or the northeast. Always. That's just a standard. This could be any direction. It can be towards the southwest as well and the southeast. All right. See, because my dips will be either way. So if I have, two strikes, one's northwest and one's northeast, my dip is going to be in one of the other cardinal directions. In my northwest strike, I can have a dip to the southwest or the northeast. In my northeast strike, I can have a dip to the northwest or to the southeast. Can't be both. Has to be one or the other. So you see, I can still get, anyway, before I digress.
For the coconino. And The angle of the dip is important, or the direction of the dip is important, because that tells us which way the sand is being transported. So the sand is being transported from the north to the south based on these crossbed dips. Now you can't
north to south. So in this case, our strike would be east-west. But that's odd, north to south. Because I know young Earth creationists like to say, well, we'll just say, this is my North America. It's not perfect. I know it doesn't matter. Maybe I might want to add a little Alaska here in Hudson Bay for you all. Okay, so it's not very good. Now, according to them, the flood came upon the land, right? Well, this is my land, this is my ocean. Which direction is my flood going to come from? And, you know, Colorado Plateau and the Grand Canyon's right about there. And he said, our dip is to the south. Water going to come up this way. Shouldn't my dips be to the northeast?
Look at a face like this over here and just put a protractor on there and measure it. You have to actually find a flat surface like this on the dip, pour some water down and measure that dip.
Okay, remember how I mentioned apparent dip? You can actually measure those faces. Okay, say what you have going on here. Now we're going to be looking down at our sandstone and our crossbeds. We might have a fracture set that goes this way, and this is our north. Now our true dip of our beds, our true strike and dip, might be something like this. Okay? But I can't get this measurement for whatever reason. I can't get up there, it's not exposed. I can get lineations from these here. And in, you know, see if I can do this accurately. So if I'm staring at it, this way's north. This is me trying to do 3 dimensionals. If you're looking at the outcrop, you have your face here. You have your fracture plane here. So you have your crossbeds going this way here. And this way, they're a lot more level. You measure. Now you have to do this from the same bed. You can't do it from different beds, crossbeds. So remember, this is where my true thing would be. It would be, you know, my true, it would be like this. But I can't measure that. But what I can do is take 2 lineations. I can take 2 lineations. I can take we'll use this bed because I have good exposure. So I take 1 lineation here and 1 here. So I read the dip. I put my Brunton on that face. Like this is the face. And I turn it to that line, that dip. So my Brunton's facing this way. You know, we got my Brunton and she's facing this way. Okay, right there. And I directly read that dip. It doesn't matter if I'm on strike or not. It does not matter. And then I would write it, whatever it is. I'm pulling these numbers out of my backside, but just to show you, so I don't know if this is what they would be. But say I got a dip of about, obviously that's more than 10 degrees. I would write it in my field notes as 10 degrees to the south 10 west is what that looks like. Okay, and I do the same thing for this. And then I write it and I get, we'll say 15, okay? So I get 15 on this face, and I put this in here. Why don't I draw the degree sign? Because if I'm a sloppy writer, my field book, that could look like a 0. All right, that's one way to do it. Some people put a slash, but then that could look like a 1. You know, if I'm a sloppy writer and I write a degree like that, or if I write my slash like that, it kind of looks like a 1. So you put colons. That's just something I do when I'm reading my field book. So that'd be 15, looks like to the north, 75 west. I would plot these two either graphically or calculate it, and I should get this. So you can get true strike and dip from apparent dips. They're lineation measurements. I'm not going to go into the details on that. I was going to show you how you can do it graphically, but this video is going to be ridiculously long as it is. So let's move along here. By the way, I'm hot. It is hot here. Complain. All right.
It's possible to put your compass up against a flat surface like this and make the measurement from underneath. And you, of course, can't pour water down that, but you can move your compass around and find the maximum dip. However, if you come right up here and just look at the flat face right here, it looks like these beds might even be flat, but they're not flat. If you look right up above, the dip is just like that, is slightly at this angle. So it's very important to find this a flat surface that you can make a measurement on. And we have been measuring a number of these cross beds in the Coconino from all over the state of Arizona. So when I average all these measurements together, I come up with an average of about 20 degrees, and that's consistent with what others have found and published in the literature. And the reason that's important is because the maximum dip on desert sand dunes is right around 33 to 34 degrees, and that's called the angle of repose.
That is called the angle of repose. He is correct on that. And it depends on the sand composition and grain size. It can be more than that. That's generally true. Now, if this is a quartz arenite with rounded grains, that probably is near it. But this is below that. Now, I mean, you know, obviously the Sahara, you've seen dunes, just the dunes, because that's what a crossbed, if that would kept going, you would get crossbeds there. They can be a lot bigger than that. So that depends. It's dependent on other factors. I just thought I'd say that.
And the dips in the Coconino are much, much less than that. Even if you take into account that the Coconino has been compacted a little bit, which it has been, you can't get dips down around 20 degrees. That argues strongly. These are probably not desert sand dunes. They're more easily...
Now, I don't know if the cross beds are all that way. I can tell you by looking at this that they probably don't all have the same strike, although they might have the same about dip. So that means you've got different directions of source, even if minor. So just because 30 odd degrees is the maximum, even if that's true, that doesn't mean you can't have sand dunes less than that. I mean, it depends on the Aeolian environment. My house is just south of a dune ridge, and it's subtle. It's probably 20 degrees. And then you go further, and it just disappears, and eventually you get into other deposits. Because remember, units don't continue forever. So this is basically the end of that one. I have one more to show you with Whitmore, and I want to get into that because I think it's important. All right. And that'll be the end of these for now. And I'm actually, so far, I'm okay with this guy. And I have a little trouble with him taking his measurements. But, you know, he is trying to show you something. And explaining it that way is the simpler way than I just did. Even though mine is the way I would tell you it. Because structural geology, is it a 200 or 300 level class? I don't remember. And I've told you guys before, it's more like engineering. So it's not something 100 level students learn. So I guess I'm okay with him describing it that way. That's fine. But just keep in mind that that's not how you get strike and dip. All right. I mean, you could move it. If you don't have water, you could move it till you get the greatest dip too, but that takes time. Why not just do your strike, get your dip, and you're done. You move on. It takes too much effort. I know after a while you do get more, familiar with it and stuff. But anyway, let's move to this next segment before I digress too much.